Hi everybody, welcome back to the video lecture series on protection switchgears. Today we are going to discuss about power system basics. Come, let's go into the video. So before going to see what is a power system basics, we have to know about electrical power system structure. This is the basic structure of electrical power systems. Here, first the power is generated in the generated station. Here we can see first the power is generated in the generation station. It may be in a power plant, uh, example solar, wind, whatever, renewable sources and non-renewable sources, whatever may be. So this generated power is transmitted with help of the or transformer, and with the help of the transformer the power is transmitted through the transmission line, and finally from the transmission line again the power is given back to the transformer, and from the transformer again it's transmitted to the commercial or residential buildings. So this is the basic structure of electrical power system. Okay. Here the first what is electricity is generated at the power plant. So any power plant, we have a solar, wind power plant, thermal power plant, hydro power plant. We have so many power plants, and the voltage is stepped up from the transmission. So first the generated voltage is step up with the help of transformer by using transmission line. Okay. So the next one is the next part, the energy travels along the transmission line to an area where the power is needed. So the power is transmitted where the power is needed. And the voltage is decreased or stepped down at another substation. And finally, receiving in substation, the voltage may be decreased or increased according to the application's usage and the distributed power line. Here. And find that carries the electricity utility, it reaches the home or business. And finally, the power lines carries the power to the utility where it is needed, whether it is a commercial building or residential house, etc. This is the basic structure of electrical power system. Okay. Now, this is in a single line diagram of electrical power system. What is a single line diagram? So, single line diagram, here we have a generator, and we have a transformer. This is what a single line of electrical power system. So before in previous slide, we have seen the basic structure. Here we have a pure single line diagram of electrical power system. It's entire structure. Here we have generator and transformer, the transmission line with the help of sending in bus bar, and we have a transmission line, and we have receiving in bus bar, and finally we have step up or step down transformer, and finally we are going with the motor or whatever load we require. Okay, this is what a single line diagram of electrical power systems. This is also a single line diagram. Here we have a bus bar, we have a transformer, and this is the receiving and transformer, finally motor. This is a single line diagram. It's now coming to what is the importance of protective schemes for power electrical apparatus or power. So this is an important thing. Why we need to protect the electrical apparatus in power systems. So main thing why we need to protect. Let's go and see into the next slide. So here, first thing, we have our basic symbols. Here we have so many symbols. This symbol represents two transistor winding. This two transistor transformer, two winding transformer. This generator, bus, transmission line. This is a delta connection and V connection. This is static load. We have this is a current transformer symbol. This is a voltage transformer. This is a capacitor. And this is what circuit breaker. And this is the fuse, and we have surge arrestor and disconnector. These are all the basic symbols of we are using in this power systems. And what is the primary equipment components needed? So what is the very components needed for power system? We know the transformer. So transformer is used to step up and step down the voltages. And breakers. So the breakers to energize equipment and interrupt fault current to the isolate the faulted equipment. Here, what happens? The breakers isolate the fault equipment from the power system. Okay. So next one is insulators. So insulator to insulate the equipment from ground to other places. So from ground to other places, what happens is insulator isolate. Okay, insulator and isolator, that is switch. So to isolate the fault equipments from the power system. So to create an visible and permanent isolation of a primary equipments from maintenance purpose or root power flow over certain buses. Okay. Finally, buses. What is buses? To allow the multiple connections feeds to some sources of power transformer. This is what it allows the multiple connection. Bus is allows the multiple connection. There is a feeder like an brain of an power system. Buses from how we are seeing that the nerve system, from the nerve system, the so many nerves goes around our body. The same thing, the bus allows the multiple connection period to the same source of power transfer. Okay, these are the primary equipments and components of uh, power system. The next one is primary equipments. Here are the some of the primary equipments. That is what grounding and arrestor and switchgear and reactor and voltage transformer and current transformer and regulators. These are the main primary equipments which needed in a power system structure. Okay. So here the arrestor, what happens here? Arrestors to protect the primary equipments of sudden overload or lightning strike. If the sudden overload because of the lightning stroke natures, the arrestor plays a vital role and isolate the entire power system from the faulted control, the switch gears. Here comes the switch gear, integrated component with switch or protect or meter and control power. It integrated component which consists of, it can switches on off, it can protect the device, and it can meter, it can measure, and it can control the power flow, etc. This is the main thing we are going to study in this lecture video series. Okay, this is the main thing. And the reactor to limit the fault current series or compensate for charges current, that is in a shunt reactor. And we know that voltage transformer and current transformer, and also primary current and voltage supplies and scale down values to PCs and meterings and SCADAs, etc. And regulators, we have know that regulators voltage, current, and voltage regulator, phase angle, etc. Okay. So next thing is why we need a power system protection. This is a basic question. Why we need a power system protection? The first thing is there is no fault-free system. The main thing is there is no fault-free system in an entire power system. So to ensure the safety of a personnel, so main thing is there is no fault-free system. Next one is we have to ensure the safety of the persons. And third one is usually faults are caused by breakdown of insulation due to various reasons of system overload, over voltage, and lightning. So these are the main thing. Because of this, we need power system protections. Okay, power system need to be protected. And protected power systems. Here we can see what is protected power systems. The series of device whose main purpose is to protect person and primary electrical power equipments from the effect of fault. So protected system, that system should protect the human and the equipment from fault. Okay. And we have know that what is blackouts. The blackouts is in a entire system gets fault and entire system comes to the fault. So here, what are the characteristics of blackouts is losses of service in a large area. So the entire area, the large area or a populated region. It's an example, the southern zone. We can take it as a zone, the southern zone. The southern zone completely it's a blackout. And what happens, loss of services without of the power supply, what happens, we are facing so many problems. So what are the problems? The overreaction of the protection of the reaction vein causes the overreaction of the protection of the system, and this is a hazard to the human life and may result in enormous economic losses, economical losses. Okay, so because why this happens, main is overreaction, and the next one is bad design of protection systems. These are the main two causes of this blockouts. Okay, so without the protection system, these may occur. This is the primary protection system. This we have already discussed, and this is a backup protection and the protection power system protections without this. Here we have an elements. We have current voltage transformers, relays, circuit breakers, batteries, fuses, lightning arresters, etc. Okay. Here we have current transformer, voltage transformer, relays, and we have here we can see this is the relay. When the contact switch is closed, what happens? This get energized, and what happens? This contactor gets attracted. Okay, so this is the relay, and this is what circuit breaker. When this breaker is in off position, now when it is on position, what happens? The supply gets entered. The supply gets entered. You can see this when it is on position, supply get entered. Okay, so with this, we can end up with today's video lecture, and we can see you next video lecture. Thank you so much for watching this video.